Hi, I'm here to talk to you a little bit more about energy, and particularly two forms of energy: gravitational potential energy and kinetic energy. Now, I said potential energy is any form of stored energy, but oftentimes when I talk about potential energy, PE, I'm really going to be talking about gravitational potential energy. It's kind of like the shortcut word. When I say, oh, potential energy of this object is, I'm usually talking about gravitational potential energy. And gravitational potential energy is dependent upon the position of an object above the ground. So I have a box up here, and I'm going to say that this box is on an incline, and let's say that it is a 2-kilogram box, and it is at a height of 5 meters. If I want to figure out what the gravitational potential energy is, it's just PE equals the mass times G, the constant, G 9.8 meters per second squared, times the height above the ground. Now I want to also point out that mg, we've seen that before, mg is really just the weight. So you could also write this as F sub g being the weight of the object times the height. Either way works, but this is the equation that you'll see on your reference table. So let's say that I have a 2-kilogram box. It's 5 meters above the ground. Turns out that the incline does not affect the gravitational potential energy at all. So it ends up being 2 kilograms times 9.8 meters per second squared times the height of 5 meters. We throw this into the calculator. And you should get, I don't even need the calculator for this, because 2 times 5 is 10. 10 times 9.8 is 98. Should get 98 kilograms meters squared per second squared. And it turns out, I said that energy is usually measured in joules. A kilogram meter squared per second squared is the same as a joule. So the potential energy of this is 98 joules. Sometimes we'll put a little g on here to indicate that it's gravitational potential energy as well. So you should look out for that. Now let's take that same box, and it doesn't really matter how fast, if it was moving at all when we hit that point. But I'm going to say, for example, that it is sliding down here, and at that point that we have measured 5 meters above the ground, its velocity is 3 meters per second. So we basically took a snapshot of the box when it was sliding down the incline, and the velocity does not affect the gravitational potential energy, because we know that energy related to motion is going to be kinetic energy. So the kinetic energy of an object depends on a couple of factors, the first of which is the object's mass, and the second is the object's velocity, 1/2 mv squared. Now note that velocity is squared. This is an exponential relationship. So if you were to graph kinetic energy versus velocity, you'd end up getting a curve like that. I can solve for this. I said 1/2 times 2 kilograms times the velocity of the object, 3 meters per second, and that is squared. So you end up getting 1/2 times 2 times 9 kilograms meters squared per second squared. 1/2 of 2 is just 1, so you have a total kinetic energy of 9 kilogram meters squared per second squared, which is the same as a joule, 9 joules of kinetic energy. So you can see that this particular object has a lot more stored energy in the form of potential than it does kinetic energy. And 3 meters a second is not all that quick. It's about a little more than 6 a little bit more than 6 miles an hour. It's about as fast as people might walk. But clearly, as it descends the incline, the height is going to decrease, which means it's going to lose gravitational potential energy. This number is going to go down, but it will speed up, so this number will go up. And you'll see as this goes down, this goes up. If you want to talk about the total energy, and really there's a lot of energy that has probably internally and stuff like that. So let's just talk about the total mechanical energy. And we can just add the two together. It's got 98 joules of potential energy and 9 joules of kinetic energy. So the total energy is going to be equal 98 plus 9, which should be 107 joules. And what we'll find out is that if this is a frictionless slope and you ignore air resistance, this total mechanical energy should be conserved. So even as it gets lower on the slope, it should still have 107 joules. But what's going to change is that the potential energy goes down and the kinetic energy goes up. What else? There's one other thing I wanted to just point out. If we say that this is a 2 kilogram box, that means that sometimes you might see it defined as a 19.6 Newton box, because that would be the object's weight. The object has a weight of 19.6 newtons. So you end up getting the same answer here if you just say 19.6 newtons times 5 meters is the height. You should get 98 joules as your answer. So just be aware to make sure whether you're seeing an object's weight or an object's mass. And you can always transform from one to the other if necessary. But if you have the weight, you don't need to find the object's mass, because you can remember mg is already a part of this equation. Okay, thank you very much for watching.